Friends, a karate master in this picture is trying to break the stack of boards. Now the question is, how does a karate master breaks a stack of boards with a single strike? How is this possible? And also, in cars, there are these zones called crumple zones. Why are these? Why cars are not designed without this zone? Why it is necessary? So we will try to answer these questions during this lecture. And here you see when egg drops from some height, it breaks. So now the question is it possible to make an egg drop safer? We will try to answer this as well. The answer to these all questions lies in understanding of impulse. What is this impulse? Now let's try to understand. So impulse is the product of force applied to an object and the time during which the force is applied. So simply you can say the product of force times the duration during which the force is applied. If you see this person, he's throwing the ball, and as ball strike with the curtain, the force applied to the curtain and the collision time of this ball with the curtain is the product of these two gives you impulse. So now let's try to understand this equation. So if the force is higher, the t, the duration collision time will be lower. And if the collision time is higher, then force will be lower. So we can understand by this table. So initially, if we want to keep the impulse same, 100 units, then the force initially is 100, but the time is 1 second. When you multiply these two, you will get 100. And in second case, if you decrease the force to 50, then the time must increase to make the impulse 100 units. Similarly, you can further decrease the force, and you can increase the time, and now it again makes 100. And similarly, you can decrease the force, and if the force is 1 Newton, then the time of collision will be 100 seconds, and these two, when you multiply, you will get again 100 units of impulse. So you see that if you decrease the force, then the time of collision increases. So by increasing the time of collision, you can decrease the force applied on an object. So we can say a big T means a little f, and a little t means a big F, big force. If time is small, the force will be bigger. Now we understand that the impulse is equals to the product of force and the duration of time during which that force is applied. So now we can move on and we can ask our question again. How does a karate master break a stack of board with a single strike? And in this animation you can see that when he is going to strike, he will strike very fast, and as he is striking very fast, so the collision time is very less. So as the collision time is less, it will have more force. So with the large force, he is able to break the stack of boards very easily. And also in the cars there are crumple zones, and I asked why there are crumple zones in the cars, why cars are designed with these crumple zones, because these crumple zones allows when the cars collide during the accidents to increase the time of collision. The time of collision increases, so it produces less force on passengers so that they will be safe. So a car crash, compass zones are designed to increase the time of impact. By increasing the time, the force on passenger is reduced, and that's what saves the lives of people. There was another question in my initial slides, and that was the egg drop. And here you see egg breaks when it falls from some height. And I asked, is it possible to make an egg drop safer? And the answer is yes. And that is possible by increasing the time of impact. So if we increase the time of impact, then the force will be less, and hence it is possible. But how can we do it? We can do it by making a soft landing pad, so increases impact time and reduce the force on the eggs, and in this way it will minimize the chance of breaking of egg, so egg will not break. Now the question is there any relationship between the impulse and momentum? So as we know that momentum is the mass time velocity, and impulse is the force time the duration of time. So how can we make a relationship between these two? So if we replace this F, because according to Newton's second law of motion, F is equals to mass time acceleration. If you replace this F with m times a, now what is acceleration? Acceleration is the change in velocity with time. So if you replace this with a with delta v over delta t, you will get this relation. So now if you see here you have time, and here in numerator you also have time. So if you have a time in numerator and also in denominator, they will cancel out each other, and you will get impulse is equals to mass time the change in velocity, and this is actually what this is equals to change in momentum. So impulse is actually the change in momentum. So if there is a change in momentum, there is impulse, there is a force applied on that object for some period of time. So impulse and change in momentum, they are same thing. Next, we have one activity, match the concept. Impulse. What is this impulse? Impulse is force time, change in time. So this correctly match with this one. Momentum. Momentum is mass time velocity. Crumple zones, short time, high force, longer contact, better results, increased impact time. So crumple zones are designed to increase the impact time. So if the impact time is increased, then the force will be lower. Kratom strike, it will have shorter time because he's striking very fast, short time, and high force. So hence the stack of boards can break. Soccer kick, longer contact, and that gives you better results. Now students, you have another activity for true or false. So crumple zones reduce the force on passenger. Is it true or false? Yes, crumple zones are designed to reduce the force by increasing the time, so it is true. Next, impulse is same as force. Impulse is same as force. But we know that impulse is equals to force times the the duration of time. So it is not same as force. So it is false. Next, a longer contact time reduces Now students, today we learned that the impulse is the product of force and time. So it is simply the product of force and the duration of time during which the force is applied. We also come to a conclusion that the impulse is directly related with the change in momentum. And we saw some examples of crumple zones, egg drop, how can we make it safer, and in this way we conclude these lessons of today. Now students, there is an exercise and it asks, why do we bend our knees when we jump down from higher positions? Why we do this? We do this because when we jump, initially we have momentum from falling, and as we strike the ground, we come to rest, so there is zero momentum. The momentum must goes to zero. So there is a change in momentum. And this change, if there is change in momentum, there is impulse. And impulse is force time delta t. So if you jump without bending your knees, the time of collision with ground will be very small. And if the time is small, the force will be higher. That can damage your joints. But if you bend your knees, actually what you are doing is when you strike the ground, you are increasing the time of impact. So by increasing the time of impact, you are actually decreasing the force on your joints. In this way, you save yourself from injury. So bending knees, your body lowers gradually, spreading the momentum change over a longer contact periods. So in this way, it reduces the force and this minimizes the stress on your bones. So hence lowers the risk of injury in your joints. Now homework time. So students, you have this homework, page 166 and 167 problems. And you can also answer this question, why do athletes bend their knees when landing? Thank you.